Welcome to Module 8 of the AI and Machine Learning course. Module 8 explores model evaluation and validation in machine learning, covering methods like train-test split and cross-validation, key performance metrics for classification and regression, and concepts such as ROC, AUC, bias, and variance to ensure reliable model performance. Learning objectives. By the end of this module, you will be able to 1. Implement methods for model evaluation, including train-test split and cross-validation. 2. Use evaluation metrics to assess model performance for classification and regression tasks. 3. Interpret ROC curves and AUC for model comparison. 4. Address issues of model bias and variance to improve model reliability. Model evaluation. Model evaluation is a critical step in the machine learning pipeline that involves assessing the performance of a model to ensure it meets the desired criteria and generalizes well to unseen data. Effective evaluation helps in understanding how well a model performs on various tasks and in making informed decisions about model selection, tuning, and deployment. Importance of model evaluation. The importance of model evaluation lies in its ability to provide insights into the model's accuracy, reliability, and robustness. Here are some importance of model evaluation. 1. Prevents overfitting. Ensures the model doesn't just memorize the training data but performs well on new, unseen data. 2. Checks performance on diverse data. Confirms the model works well across different types of inputs. 3. Identifies issues like bias and variance. Helps spot and correct model errors and inconsistencies. 4. Ensures high-quality results. Verifies that the model meets performance expectations and quality standards. 5. Aligns with objectives and constraints. Ensures the model supports the goals and limitations of the project. 6. Guides model improvement. Provides insights for tuning and refining models for better results. 7. Ensures real-world applicability. Confirms the model is practical and effective in real-life scenarios. We will now explore detailed methods for model evaluation and validation to enhance the performance and reliability of your machine learning models. Train-test split. The train-test split is a basic method used to evaluate the performance of a machine learning model. It involves dividing the dataset into two subsets, the training set and the test set. 1. Training set. Used to teach the model by adjusting its internal parameters. 2. Test set. Used to check how well the trained model performs on new data. Procedures in train-test split. 1. Split ratio. Common ratios for splitting the data are 70-30 or 80-20. Where the larger portion is used for training and the smaller for testing. 2. Shuffling. Data should be shuffled before splitting to ensure that the subsets are representative of the entire dataset. Advantages of train-test split. 1. Simple and easy to implement. Train-test split is straightforward, quick to apply, and suitable for beginners. 2. Provides a quick estimate of model performance. It gives an initial measure of how well the model generalizes to new data. Disadvantages of train-test split. 1. Performance estimate can vary by split. Different train-test splits may lead to inconsistent evaluation results. 2. Limited data affects reliability. Small datasets may not provide an accurate picture of model performance. K-fold cross-validation. The dataset is divided into KKK equal-sized folds. The model is trained on K-1, K1, K-1 folds and tested on the remaining fold. This process is repeated KKK times, with each fold serving as the test set once. Procedures in K-fold cross-validation. 1. Divide the dataset into KKK folds. 2. For each fold, train the model on K-1, K1, K-1 folds and test on the remaining fold. 3. Average the performance metrics across all KKK folds to obtain the final evaluation score. Advantages of K-fold cross-validation. 1. Provides a more comprehensive evaluation by using different subsets for training and testing. 2. Reduces the variability in performance estimates compared to a single train test split. Disadvantages of k-fold cross-validation. 1. More computation. Runs multiple training cycles, so it's slower. 2. Risk of data leakage. Needs careful splitting to avoid biased results. Evaluation metrics for classification and regression. 1. Classification metrics. For classification tasks, various metrics are used to evaluate the performance of the model in predicting categorical outcomes. Accuracy. Overall correctness of the model. Precision. How many predicted positives are actually correct? Recall. How many actual positives the model correctly identified? F1 score. Balance between precision and recall. Confusion matrix. Table showing correct and incorrect predictions. 2. Regression metrics. For regression tasks, metrics evaluate the model's ability to predict continuous outcomes. Mean absolute error, MAE. Average of the absolute differences between predicted and actual values. Mean squared error, MSE. Average of the squared differences between predicted and actual values. Root mean squared error, RMSE. Square root of MSE shows error in the same units as the output. R squared, R superscript 2. Shows how well the model explains the variability of the target variable. Advantages of regression metrics. 1. Provides a comprehensive measure of model performance across different threshold values. 2. Helps compare multiple models objectively using standardized benchmarks. Disadvantages of regression metrics. 1. Each metric has its own strengths and limitations, and relying on a single metric may not provide a complete picture of model performance. 2. Some metrics can be misleading in imbalanced datasets or without proper context. Receiver Operating Characteristic, ROC, curves. Receiver Operating Characteristic, ROC, curves are used to evaluate the performance of classification models by plotting the true positive rate, sensitivity, against the false positive rate, 1, specificity, at various threshold levels. Let's explore the types of rates in ROC. Receiver Operating Characteristic, ROC, curves. 1. True positive rate, TPR. Measures how well the model correctly identifies positive cases, e.g., correctly detecting patients with a disease. 2. False positive rate, FPR. Measures how often the model incorrectly labels negative cases as positive, e.g., wrongly diagnosing healthy patients as sick. Procedures in Receiver Operating Characteristic, ROC, curves. 1. Calculate TPR and FPR for different threshold values. 2. Plot TPR versus FPR to create the ROC curve. 3. The area under the ROC curve, AUC, provides a single metric to summarize the model's performance. AUC, area under the curve. The AUC measures the overall ability of the model to discriminate between positive and negative classes. It is the area under the ROC curve. Interpretation. AUC equals 1. Perfect model with complete separation between classes. AUC equals 0.5. Model with no discriminatory power, random guessing. AUC less than 0.5. Model performing worse than random guessing. Advantages and disadvantages of AUC, area under the curve. Advantages. 1. Provides a comprehensive measure of model performance across different threshold values. 2. Useful for evaluating models with imbalanced classes. Disadvantages. 1. May not capture performance nuances for specific threshold values. 2. ROC and AUC are more relevant for binary classification tasks. Model selection and comparison. Model selection. Model selection is the process of picking the best performing model based on accuracy, efficiency, interpretability, and complexity. Model comparison. Comparing models involves analyzing their performance on the same dataset to determine which model performs best according to the chosen metrics. Criteria for model selection. 1. Performance metrics. Evaluate models using metrics such as accuracy, precision, recall, F1 score, MAE, MSE, etc. 2. Cross-validation. Use cross-validation results to assess model stability and generalization. 3. Complexity. Consider the model's complexity and training time relative to its performance. Techniques on model comparison. 1. Benchmarking. Compare models against a baseline or reference model. 2. Statistical tests. Use statistical tests, e.g., paired t-tests, to determine if performance differences are significant. Advantages of model comparison. 1. Helps in selecting the most appropriate model for the task. 2. Allows for an objective comparison of different models based on quantifiable metrics. Disadvantages of model comparison. 1. Model selection can be influenced by the choice of metrics and validation strategies. 2. Comparing complex models can be challenging and may require careful analysis. Summary. In this module, we emphasized the importance of evaluating and validating machine learning models to ensure their effectiveness and reliability. This module taught key evaluation methods, metrics, and bias variance handling to assess and improve machine learning model performance. Well done on finishing the module. You've learned how to evaluate and validate machine learning models using various metrics and techniques like cross-validation and ROC curves. You're now ready to assess model performance and make improvements confidently. Keep up the great work.